Hi guys, welcome back to another video. So today I'll be doing this question from the 2007 SMC. So it says the largest circle which is possible to draw inside triangle PQR touches the triangle at ST and U as shown in the diagram. The size of STU is 55. What's the size of PQR? So the angle we're looking for is going to be here. The fact that PQ and QR touch the circles means they're tangent to the circle. So if we want to work out this angle, what we can do first is draw a line going from U to the radius, and same with S. This means that this would be a tangent line, which would make these angles 90 degrees, because a tangent and a radius meet at 90 degrees. Now we can work out this middle angle over here using the rule that angle at centre is twice the angle at the circumference. So let's call this point X. So UXS, that's going to be 55 times 2, which is 110. So if we know this is 110, we can see here we've got a quadrilateral, and all the angles add up into quadrilateral add up to 360. So 360 is 110 plus 90 plus 90 plus PQR. We get that PQR equals 70, so the answer is D. Okay, so now this is the question 24. So it says a paperweight is made from a glass cube of side 2 units by first shearing off the 8 tetrahedral corners which touch at the midpoints. That's what the tetrahedral corners are, of the edges of the cube. The remaining inner corner of the cube is discarded and replaced by a sphere. The 8 corner pieces are now stuck onto the sphere so that they have the same positions relative to each other as they did originally. What's the diameter of the sphere? This is quite a lot of waffle. All you need to know is that the side of the square, that's 2, therefore the length of each tetrahedral is going to be 1 because it meets at the midpoint of it. So now what we want to work out is the diameter of the sphere. First, this question is quite fiddly, but first things first, we're going to work out this length over here. So I'll try to draw it so it's a bit clear, but I can't make any promises. So basically we're going to work out this length if you can see it clearly. Okay, to work out that length we're going to use Pythagoras. So I'm going to call this AB. AB squared is going to be 2 squared plus 2 squared, so we get 4 plus 4. AB squared equals 8, so AB equals 2 root 2. Now that we have that, I'll call this C. CB squared is going to be 2 squared plus 2 root 2 squared, which gives us 4 plus 8 CB squared, and that equals 12, so CB equals 2 root 3. Now, we know what CB is going to include, and that's going to be the height of the tetrahedron, because it's going to go through the height of both the tetrahedrons that touch the sphere and the diameter, because it's running through the centre of the sphere. So we could say that 2r plus 2h, where h is the height of the tetrahedron, equals 2 root 3. Now we can work out the height of the tetrahedron, but this is a bit fiddly. So imagine you have the centre of the tetrahedron, there's 3 sides, they're all the same length, which would mean that it'd be split from the centre. It'd be split like this, which means that each of these equal triangles is going to be 120 degrees. So we know that the tetrahedron, each of its length is 1, so let's imagine it from this perspective, or a bird's eye view of one of them. We'd have one over here, one over here. So we want to work out the hypotenuse. That's obviously going to be root 2. So here, this is another perspective of it. The base would be root 2 over here. And we'd obviously have equal sides here, so x 120 root 2. Here you could just use the cosine rule, so 2 is going to be equal to x squared plus x squared minus 2, x squared cos 120. So we get 2x squared plus x squared equals 2, so 2 equals 3x squared. So 2 over 3 equals x squared. So root 6 over 3 equals x. But that's not the height, that's just the base. So if we want to work out the height, we know the hypotenuse is going to be 1, and so call this the height. This is going to be, the adjacent side is going to be root 6 over 3. So if we want to look at the height, it's going to be 1 squared minus root 6 over 3 squared, which is just 1 minus 2 over 3, which is 1 over 3. So the height's going to be h squared, is going to be square root of 1 over 3, which is root 3 over 3. And now we can just substitute this into our original equation. So 2r plus 2 times, which is going to be 2 root 3 over 3, equals 2 root 3. So now we just take away 2 root 3 over 3 from 2 root 3. So we get 2r equals 4 root 3 over 3. But it's not asking for the radius, it's not asking for the radius, it's asking for the diameter. And as you know, diameter is twice the radius, so the actual answer is just D. The diagram shows two different semicircles inside of a square of side length 2. The common centre of the semicircles lies in the diagonal of the square. What's the total shaded area? So, as we know, each of the side lengths is going to be 2. And I'm going to call the radius of the small semicircle and large semicircle y and x respectively. So that's small and that's large radius. Okay, so first thing I'm going to do is I'm going to draw a line from here all the way to the other end of the semicircle, and same for the other side. This would mean that this angle is 90 because in a triangle where the hypotenuse is the diameter, the angle will be 90. Therefore, this hypotenuse is going to be 2x squared, and I want to work out what these lengths are, so I'm going to call them A. So it can be equal to 2a squared, so 4x squared equals 2a squared, so a squared equals 2x squared, so a equals x root 2. And as we can see now, we've got a square. This centre is going to be the centre of the square because it's the centre of the semicircle. Therefore, if we draw another line over here, as you can see, we'll get our length over there. This is an isosceles triangle, so we've got our y and our y over there because that's the radius of the small semicircle. And as we can see, this bisects the length, therefore y is equal to, I actually made a mistake, so y is not equal to x root 2, it's equal to x root 2 over 2 because as I said it bisected the length. So y plus x is still 2. We get x plus x root 2 over 2 equals 2, so we get 2x plus x root 2 equals 4, so if we factorise out x, we get x equals, let's rationalise this, 4 minus 2 root 2, which means y equals 2 minus 4 minus 2 root 2. Therefore, y equals root 2 over 2 minus 2. Now what you're going to do is work out the area of the large semicircle and the small semicircle, add them together to get the total shaded area, and factorise your answer. Thank you so much for watching.